Today we'll be seeing the formulae and the concepts related to circles. Words to remember: circle, semicircle, radius, diameter. Now for the diameter, make sure you don't get the spelling wrong. It's M-E-T-E-R and not R-E. Chord, sector, segment. I'll be drawing three figures. Now let me label them as A, B and C. Now each of these red lines have a name, and let's try to identify them first. We have the diameter, the chord and the tangent. You have to note that the tangent touches exactly at one point to the circle, and this is called the point of contact for the tangent to the circle. These are chords. Now the specialty of a chord is the endpoints of the chord lies on the circle. Now here again, diameter is the longest chord and it passes through the center O, and if this is the radius R of the given circle, then now to find the length of this diameter, let us consider the diameter length to be D. So D is going to be equal to twice the radius. So I can write 2 multiplied by the radius, and my formula is D equals 2R. So this is a formula that you need to remember. Why is it 2R? You can see here, this is also the radius. So the total length, the red line, is your diameter. D is R plus R, or it's D equals 2R. Moving on to the next part, talking about the area of the circle. We take the center O and the radius of the circle as R. The area of a circle is given by the formula pi r square. Now where pi stands for the constant, which is 22 divided by 7. On your calculator, you can directly type the constant pi. As you already know, pi is a Greek letter and it is irrational. And from the formula, we can make out the unit. It's r squared. So if r is in centimeters, so centimeters squared is the unit of area. Here you have a semicircle. We have the radius here as r centimeters. Now let's connect it to the previous formula. The area of a circle is pi r squared. So for a semicircle, we are just taking half of this area. So the formula is going to be pi r squared divided by 2. Again, we have a circle with radius r centimeters. Now let's talk about the circumference. Circumference is nothing but the perimeter. Or the outer border. You can see the thick black border that is surrounding the area of the circle. To find the circumference of the circle, we have the formula. Now I consider the circumference with the letter C. So C is equal to 2 pi r. From the previous section, we saw that the diameter D is twice the radius. So you have 2 and r here. So you can also remember as circumference is equal to pi d. So whichever is easier for you, you can use or you can memorize the easier formula. Okay. Now some students get confused with the area and the circumference. So if it is the r that is confusing you, whether it is just the squared or it is just the r, if that is a confusion, you can remember for the area it is pi r square, and for the circumference it is pi d. So you're just removing the r from here. That is one easy technique. Pi r square for the area, pi d for the circumference. Moving on to the next part. Now discussing the circumference of a semicircle, we have to remember two figures. It is clearly visible that for the figure, I'll be labeling the figures as semicircle A and semicircle B. For the semicircle A, talking about the circumference, I just need this border which is in black. Okay, and for B, I have a closed region. You can see that you have the arc part along with the straight length here. So it's a closed border that we are talking about. So see here, the circumference is going to be 2 pi r divided by 2, which is just a pi r. So circumference here is pi r. While for this figure, now this is going to be pi r, right? And this is the long diameter of the circle, which is 2r. So the circumference here is going to be pi r plus 2r, which can also be written as a pi r plus d. You don't have to memorize both these. The basic formula starts from the circle. So if you can memorize the area and the circumference, that will be enough to make the other two formula for the semicircles. I have put two figures here, one green and the other in a red shade, figure X and figure Y. Since you have some idea about sector and segments from your prior knowledge, I would like you to try to identify them. Take a moment. Figure X is talking about sectors. In a sector, you can see that the central angle here, the 360 degree, is getting divided. If this is an angle theta, theta is again a Greek letter, the remaining angle is going to be 360 minus theta. So this is how a sector looks like. A sector makes an angle with the center, and in figure Y you can see it has no connection with the center, and here it is just a chord AB that you have, and the chord AB is dividing the circle into two regions, and this region is called a segment. To be more specific, this is going to be a major segment, and this is a minor segment. So this is a segment and the other is a sector. This figure should give you a clear picture to differentiate on a sector and a segment. Now in a sector, it's the arc that divides the circle. You have the major arc, the minor arc. This is the major sector, and this is giving you the minor sector. So the region X here is a sector of a circle, while the region Y is the segment of a circle. So I hope this picture clearly explains the difference between a sector and a segment. You can call this green region as a minor sector, and the remaining being the major. This yellow region as a minor segment. Coming to the formula to find the area of a sector, we know the area of a complete circle is pi r square, and we are only talking about this green region which makes an angle theta here. So the complete angle is 360, and out of 360 we are only talking about an angle or a section which makes an angle theta. So theta out of 360 is the portion that we are talking about. So the area will be theta over 360 times pi r square. So this is the area of a sector. Talking about arc length, we're talking about this arc here. I've just highlighted it, giving it a red. We know the circumference of a complete circle. We are talking about the complete border of a circle. It's equal to 2 pi r. And we are only talking about this arc which makes an angle of theta here. So again, taking the fraction, theta over 360 times 2 pi r, which is the circumference of the complete circle. And remember, the letter L is used to denote the arc length. Now here you have a question. We have formula to find the area of a circle, the circumference, the sector area, and the arc length. The question is, how will you find the area of a segment? Watch the visuals carefully. We have A and B as the endpoints of the chord that divides a circle into the major and the minor segments. So what we do, considering the center as O, if we join the points A and B to the center O, we can have a major sector, the complete green region forms a minor sector, now our interest is in the minor segment, which is the green region below. So from the figure, we know the area of a sector. Now if this angle is for the angle theta, the sector area is equal to theta over 360 times pi r square. From that, you're subtracting the triangle area. Now triangle area is given by, this is the radius, and you have the angle theta, so 1 by 2 r square sine theta. This is the formula that we'll be using, which is from trigonometry. Half r square sine theta, you can write it as r square sine theta over 2. Now using these two, we can find the segment area is equal to sector area minus the area of a triangle, which is written as theta over 360 times pi r square minus r square sine theta over 2. Taking you back to the formula, you have the minor sector area from which you're going to cut off the area of a triangle, giving you the segment area. A quick summary: area of a circle pi r square, area of a semicircle pi r squared divided by 2. Circumference of a circle, 2 pi r, or you can write pi d. Circumference of a semicircle, we are dividing this by 2, so it's pi r or pi d over 2. Area of a sector equals theta over 360 times pi r square. Theta is the angle in degrees. Arc length L is equal to theta over 360 times 2 pi r, or you can also write theta over 360 times pi d. Area of a segment equals sector area minus area of a triangle, which is equal to theta over 360 times pi r square, which is the sector area, minus r square sine theta over 2. That's it for the day.